Alright, in this video, I'm going to be talking about span in linear algebra, and we can define the span of a set of vectors as the following. Span is the set of all possible linear combinations of the set. So the span is a set of all possible linear combinations of the set of vectors that you're given, which means that set of all the possible combinations where you have a constant times the first vector plus a constant times the second vector plus a constant times the third vector. So we have it C1, C2, C3. These are all real numbers, and you can change these to wherever you want. And all the possible combinations that you can make like this, that is the span of a set of vectors. So to start off, I think it'll do good to give an example that's a little bit more concrete. And I think it makes the most sense to start off in the plane, R2, because that's something that's commonly used and it's easy to see. So you have the y-axis and x-axis, and let's say that you have two vectors in the plane. Now, let's say that our first vector is just shooting up like that, and then the second vector here is something that resembles like y equals x. So the set of all the possible linear combinations here, well, let's start off with 1. A linear combination here is just adding these two vectors as they are, which if you add these two vectors, it's the sum of both their horizontal and vertical distance, and you can do it with like the parallelogram visualization, which is also like you can move the bottom of this vector to the tip of this one, and then wherever it lands up here is the sum of the two vectors. So we can see that adding these two vectors, we reach this point in R2. Now, going back to scaling them by constants, let's say this is V1 and this is V2. And let's take 3, which that's a real number, multiply it by V1, and maybe we're somewhere up here. And then we can take the sum of this vector and we reach some point up here. So that's another point that we can reach in R2. Now we can also scale these by negative numbers. So let's say that we multiply V1 by -3, right? And we're somewhere down here. Take the sum of these two vectors and you end up somewhere like here. And you can make this one negative and take all the possible combinations. And what actually happens here is as long as you have two vectors in R2 that are not linearly dependent, then your span is going to be all of R2, the whole plane. So what I mean by that is if you have V1 and V2, and let's say that we have V1 is 0, 1, 0. V2, or not 3 components, 2, because we're working in R2, right? So let's say we have 2 components, 2 variables. We have 0 and 1, and then 1, 0. Now we say that a set of vectors is linearly dependent if one of the vectors in the set can be expressed as a linear combination of others. And in this case, it's impossible because you have a 0 and a 1. You could scale this to whatever, but that's always going to stay 0. And you're never going to be able to create this vector. But if you had like 1, 1, and 1 or 2, 2, then all you have to do is multiply this one by 2, and you get this vector. So this is linearly dependent. And if they're linearly dependent, I can just draw an example where it makes like, visual representation. You have like 1, 1 is right here, right? And then, no, it's not. 1, 1 is like right here. And then 2, 2 is like right there. So clearly you can just multiply this by 2 and you reach this vector. So all the possible linear combinations here, if they're linearly dependent, it's just going to be the line that they form and not the whole plane. But as long as this is not happening, then they are considered linearly independent, and then they will take up the whole plane. So if you're asked to find, say, a vector that's in the span of some vectors. So let's say this span, you want to find the span of vectors v1, v2, v3. Well, let's define these where we have v1 as 0, 1, 0, v2 as 1, 0, 1, or 1, 0, 0, and v3 as 0, 0, 1. Then if we want to find a vector that's in the span of these, it's just going to be some vector that's a linear combination of these three, which is not very hard to do. We could say, let's do 2 times v1 plus 1 times v2 plus 3 times v3. And then we get, adding these up together, this times 2, we get 0, 2, 0. So here we get just 1, 0, 0, and here we have 0, 0, 3. So we end up with the vector 1, make sure I'm doing this right. Yeah, 1, 2, 1, 2, 3. Yeah. So this is what we end up with, and this is in the span of v1, v2, v3. So that's how you can find a vector that's in the span if you're given the vectors, right? All right, so now I'll do an example with R3. So in this example, we have 2 vectors and we want to find the span of these 2 vectors. Now, these 2 vectors can be connected just by a line like this. So, and they can also, you can draw the vectors from the origin and connect them with this line. And the set of all their possible linear combinations is going to make a plane. It's going to make a plane inside of R3. Because this is a little bit harder to see than the R2 case, but if you're scaling this vector by some value, you're scaling this vector by some value, you're adding them up, what you get is eventually some plane. So you have 2 vectors in R3 and they have 3 components. You get some plane in R3. Now what if we add a third vector, where we say our third vector is going to be something where we just do 0, 0, 1. Span of these 3 vectors. 0, 0, 1. Now imagine that we have this plane that we have created. That's not very good, but this is some plane. And then we add this third vector. That means that we can scale this third vector by any constant, and it becomes part of this linear combination, right? And what this does is it kind of shifts your plane. You can shift it up if you multiply it by a positive value, and then you can shift it down if you shift it by a negative value. And in this way, you cover the whole 3-dimensional space. So, that's another way that you can see span graphically. And although it's a little more difficult in the 3-dimensional case, or R3, the idea is the same. You're taking the sum of 3 vectors, right? And all the possible sums with different constants. And then that whole thing is their span. So yeah, those are some examples, and hopefully that made sense.